Let's practice the shortcuts from last time on this example. Let's find the residues of the function z over z plus 3 times z minus 4 squared at each of its poles. Over here, I've recopied the formulas that we came up with in the last video. At a simple pole, the residue of the function at z naught is the limit as z goes to z naught of z minus z naught times f of z. At a pole of order 2, the residue is given by the limit as z goes to z naught of the derivative of z minus z naught squared times f of z. Notice that this function has two poles. It has a pole at -3 with order 1, so that's a simple pole. It also has a pole at 4 of order 2, so we're going to get to use each of these two formulas. Let's start off at z equals -3. So the residue of the function at -3 is going to be the limit as z goes to -3 of z minus -3, which is z plus 3, times f of z, which is z over z plus 3 times z minus 4 squared. Notice here, just like in Cal 1, before we evaluate this limit, which is in indeterminate form, I can cancel the z plus 3's, giving me the limit as z goes to -3 of z over z minus 4 squared. And I can find that limit by direct substitution. Plugging in the -3, I get -3 over -7 squared, or -3 over 49. Next, let's move on and see what happens at the double pole, z equals 4. So here we'll be using the bottom formula, and the residue of the function f of z at 4 will be the limit as z goes to 4 of z minus 4 squared, the derivative with respect to z, of z minus 4 squared times f of z. Before I differentiate, let's cancel the z minus 4's. So I get the limit as z goes to 4 of the derivative with respect to z of z over z plus 3. And then we have to take the derivative before taking the limit. So to take the derivative, we'll use the quotient rule. It'll be the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. On top, I have z minus z, which is 0. So this is just the limit as z goes to 4 of 3 over z plus 3 squared. And now using direct substitution, it gives me 3 over 7 squared, or 3/49.